So you see, I was just laying in bed. It's like, man, I should get up. What if I have a student that wakes up early on a Saturday morning and wants to watch this video? What if it's not posted? What will that kid do? Watch cartoons? I don't think so. Do other homework? Blasphemy. Gotta do homework. Gotta do math homework first. And if I don't have this up, and you can't watch the video because you didn't finish notes in class, what would you do? It would be upsetting to you, I know. And I'm sorry. So I got up early. 4:10, 4:15. It's taking me a little while to get down here. It's almost 5:20 now. It's ridiculous how long it takes me to get set up. But this is a massive studio I have here to get set up. Someday I'll show you a picture of it. You guys ready to rock and roll? I'm ready to rock and roll. Rock and roll. Oh, man, let's get started on some statistics. Woo! So, let's go. What we're going to do first is just take these numbers and put them in, of course, our stupid thing's not rotating. Here we go. Ding, 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 boom, ding, boom, ding. Come on, rotate, move. Why is it doing that? I don't understand. Sometimes I got to click on other stuff. Click, click, back, rotate. No. It was just working. I swear it was just working like, oh, there it goes. Now we're back. Okay. See, it was working. So we're going to put these numbers in our calculator, and we're going to try to figure out what the mean and standard deviation is. So, let's do that. I have the list next to me, because otherwise I won't be able to see it. This one. All right. So, we go into our spreadsheet, and at the top you want to type in something like, in this case, time, T-I-M-E, and put the numbers in, 4.71. Now, in class, if you were in class, you saw me purposely make a mistake. Yeah, I purposely made a mistake. Normally, I just make them on accident. And I'll make one in this video, and you'll call me out on it, but I purposely made one because I want you all to realize that most kids get them right, but you don't want to be that kid that typed in 411 when it should be 412. And just be off by just a small little bit. Yeah, it doesn't matter. It's just a number, man. It doesn't even matter. Yeah, it does matter. Makes a huge, huge, huge difference. When you're clicking here and you can't click on anything, you're not able to click on menus, things get grayed out like this, and you can't do things. It's because you are in like edit mode of this cell. And you have to just kind of be sitting here. Just like that. So I go into menu. I'm going into statistics. We only have one variable. That variable happens to be time. So I'm going to do one variable statistics. I only have one list. Later I'll show you when we use two. You got to select that. Oh, I'm going to be using time. And click OK. And like we've said in my last video, X bar stands for your mean. And all this other stuff is meaningful too as well. So what we're going to do, the first thing we're going to do is go back to our note sheet, and we're going to write down X bar, not there, X bar equals, I think it was 4.27. Hundreds place is good. I should have told you where to round to. All right, I believe it'll also give you the median. The median is, computer's too far away from me. Median. There's my 5-number summary right there. That gives me my box and whisker plot from min to max. And right there, look at that, 416 is my median. 4.16. And the final thing I have to figure out is range. Now remember, range is an actual number. So I'll come over here and calculate it. It is max minus min. And my max is 4.71. And my min is 4.06. Don't need a calculator for that. Subtract them, you get 0.65. Now, while I'm here, just because I'm probably going to use it in a little bit, let me erase this. I'm going to write the entire 5-number summary down over here. Now, it's not part of this problem, but will be part of later. So we're going to write min. I believe that was 4.06. I think the max was 4.71. And I believe the median, which is sitting right there, is 4.16. Now I just need quartile 1 and quartile 3. 4.12. Yes, I know, it's 4 and 12 hundredths. It's just me being lazy to write 4.12. It's just an easy way to remember to bring over. And 4.425. 4.425. Yes, 4 and 425 thousandths. That's too much work. All right, we'll come back to that. We'll come back to that. So the next list's a little bit different. You'll notice that we are collecting scores. Don't know what they're scores of. Maybe they're test scores. God, I hope they're not my students. So we're collecting scores. So that is our data that we're collecting. But this column is frequency. Now, if you wanted to, you could list these all out. You could list out 48, 48, 50, 50, 50, 50, 50. But that's kind of a pain in the neck, because this means there's 6 of these. There's 2 of these. There's 6 of these, and 2 of these, and 4 of these, and this is just a much more clean way of looking at it. As I'm looking at it right now, I can see that the mode, very simply, is 50, because there's 6 of them. Mode means the most frequent piece of data, and there it is. So that's not what we're looking for. We're looking for mean, median, and range. So we're going to put these in our calculator slightly different. Let me get rid of that garbage. Don't like it. No. I hope my big head's not in the way, because I'm going to have to move it. And that upsets me. Go into my spreadsheets. In this case, they're called scores. So let me type that in. Score. And I'll go down. And, and we have frequency. I'll just put freak. Like some of my students. Or me, one of the two. I think the more time you spend with me, the freakier you get. So I'll blame myself. 50, 53, 54. Watching me put numbers in, could there be anything more exciting than that? You're thinking to yourself, God, it's Saturday. I could be doing so much more fun stuff, but instead I'm watching Mr. Krause put numbers in a spreadsheet on his calculator so I can do my homework. Ha! Amazing! It's actually fun! No, it's not. There's my list. Hopefully I typed everything in correctly. I should check it. I'm being a little lazy. I'm not going to lie. So we're going to go into menu this time. Things are a little bit different. Now, we're going to statistics. One's calculator, one statistics. Now, my one kid's class asked, should I be using 2 variables now? Because I've got 2 lists. That's not what we're doing. We have 1 variable statistics, because the only thing we're collecting is scores. That second column was just for frequency. So no, we're just using 1 variable statistic. You'll only use 2 variable statistics when you have things like height and weight, age and length of time living, things like that. We're going to just do 1 variable statistic. So I really only have 1 list of numbers, and you'll see how that comes to play in just a second, okay? So we're going to click 1 list, and you'll see why I would pick 2 lists later in a problem. But for this, we're only going to really have 1 list of numbers. But the next screen will have a slight change to it. In here, we're going to have score. But you see this thing here right here called frequency list? I'm circling it with my arrow. That's where we're going to change. In the first problem, every score number had only 1 frequency. Or I put it on the list. Now, if I had taken all those numbers and went 48, 48, 50, 50, 50, 50, 50, 50, 50, and then the frequency would be 1, because there would be 150, 150, 150, 150. But because I decided to put it into a frequency table, I have to change this and say, oh, look, I'm going to use this as their frequency. And that should be kind of obvious to you. And we'll click OK. And there it is. So my X bar is 54.3. So X bar, which is my mean, is 54.3. My median is ding, 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 ding. There's my 5-number summary. My median is 53.5. And my range is pretty obvious, just 20, but highest minus lowest, max minus min, 68 minus 48 is 20. Now you're probably asking yourself, how in the world do I have a median middle number that's a decimal? Well, if you look over here, there are, what, 20 numbers? There's 20 numbers. So I have 20 numbers in this list. That's a group of 10 numbers, whatever, this first group of 10 numbers here. And then that's another group of 10 numbers here. So what's in the middle? Well, really what's in the middle are these two numbers. You know, so in this group we went 48, 48, 48, 50, 50, 50, 50, 50, 50, 50, 53, 53. So this last number here was a 53 in this group. And the first number in this group was a 54. Well, in order to find the median when there's an even number, you have to take the average of these two, and the average of these two would be 53.5. And that's why that's that. It's so stimulating. Thanks for coming, kids. Dispersion. Whoo. Okay, listen. What dispersion means is, in layman's terms, because I like doing things in layman's terms, dispersion means the spread of the data. How spread out, or how crazy spread out is the data? Is it compact? If it's compact, that's kind of what you're looking for. If it's all spread out, you really can't tell anything about the data other than it's all spread out, and that's not very useful. All right, so in this question, let's get through some basics. We're going to continue. So we're going to talk about dispersion over the next few pages. Woo! Couldn't get that out of my mouth. Sorry about that. So this is talking about median. So what it says is, what percent of the data lies below the median? Well, if the median's in the middle, wouldn't there be 50% of the data this way and 50% of the data this way? So in this case, the answer is 50%. But I could ask above or below, and it would still be 50%. Wow, tough question. If all the data, 100%, is broken up into 4 groups, what is each percentage? Well, 25%. Why did I write that in every box? I think that was pretty obvious. Percentile. Now, I don't really like giving the official definition of percentile, but I've got it for you, just in case you wanted it. A percentile, or a centile, I don't know why I put that on there, is a measure used in statistics indicating a value by which the given percentage of observations in a group of observations fall. Is a measure used in statistics indicating the value below which a given percentage of observations in a group fall. This is more important. For example, the 20th percentile is the value for which, or score, below which 20% of the observations may be found. Let me give an example. Let's say I have a student. I'll call him annoying No. We'll just call him Bailey. He told me to give you a shout out. There it is, bro. You probably won't see it though because you're going to skip over this. Bailey, let's say Bailey is in the top 80% of all free throw shooters. Free throw. I don't think I'm saying that. Free throw shooters. Wow, that is really weird. I can't say that. So in basketball, because he plays basketball, he's all right. It's not bad. Maybe next year will be a little bit better. Anyway, let's say he's in the top 80%. Well, does that mean he makes 80% of his baskets when he's taking free throws? Probably not. But what it means is that he is better than 80% of all other b-ball players. And that's really all it means. It doesn't mean he shoots 80%. He could shoot 90%. He could shoot 95%. Probably not. But what it means is he's better than 80% of all the kids that are studied. Now, is that all the kids in the United States? No. It's all of the kids in the study. So whatever the study is. So you can make statistics say anything you want. I could say he's in the top 80% of all basketball players studied. And you'd be like, wow, he's better than 80% of all those players? And then I could have studied 4 people. Or actually, I probably couldn't have. Let's say I could have studied 10 people. And he was in the top. And I just picked like 10 random kids in the high school. And said, you guys are basketball players. Oh, look, Bailey's in the top 80%. Wow, that's awesome. Okay, so you can make statistics lie for you. So you have to be a very discerning student to understand that, yeah, sometimes statistics really don't mean what you think they mean. All right, interquartile range. Interquartile range. Often abbreviated IQR. Right? Speaking of IQ. Just kidding there, boy. You told me to give you a shout out. I'll give you a little shout out for you. Just kind of making fun of you a little bit, but I really like you, man. Anyway, IQR is defined as quartile 3 minus quartile 1. It is the interquartile range. So what happens is, if you're looking at a spread of data, let's take a look. My last test, I had a kid score not so great, and I had a kid score an amazing thing, got every bonus right that I put on the test, and I was like, what the heck? How do you do that? I mean, I put bonuses on there that nobody should have gotten right. Nobody. So you kind of freaky there. And, well, I got a couple there. I got 2. Did I have? Oh, no, that was a Heather. I thought I said more, sir. Anyway, so let's say I got a kid that got a 20% on the test. And let's say I got a kid that got 105% on the test. Well, my range here, would be 85%. Actually, my range would just be 85. My range would just be 85. So, if my range is 85 on a 100-point scale test, you're thinking, oh my gosh, these things are spread out all over the place. Your kids were crazy all over the place. I can't even taste it, but it's warm liquid flowing down the throat with a little caffeine in there. Makes me a little crazy. I'm not going to lie. If you're watching this video, you don't have me for class. 1, not sure why, but I'm glad you're here. 2, you got to think I'm nuts. I'm a little nuts. But it's fun nuts. Well, that's a little crazy. Anyway. So what happens is we don't want to look and think about all this big number sometimes. Sometimes we want to say, okay, had a bad day. Crazy smart. Let's talk about the normal people. Let's talk about that middle. If I'm talking about between quartile 1 and quartile 3, I'm really talking about that middle 50%. How spread out were they? And then if I told you their interquartile range was 10, you'd say, oh my gosh, 50% of your kids scored within 10 points of each other. Oh, that's pretty compact. That's pretty meaningful. That means, okay, they did okay. Now, does that tell you how they did? I'm hoping that 10 is closer to like the 80s and 85s and not the 50s. Because if I had 50% of my kids score between 10 percentage points of 50, or 40, that would be terrible. But if that 50% was up there in that 80s, I'd be like, all right, most of my kids did well. I had a couple kids with a bad day, and a couple kids with a freaky deaky crazy day, up here with a good day. So anyway, where'd my pen go? There it is. That's that. Box and Whisker Plot. The reason I'm gonna do this. This is from 9th grade algebra, so just a reminder. But I'm gonna use the data from up here, and then I'm gonna come back to that. So we made this. I made you do this. The 5-number summary. The 5-number summary is used for a box and whisker plot. So I'll start with my box. A lot of times you'll see a number line below. In this case, it's kind of hard to do, so I'm not going to. Quartile 1 was 41.2. I always start with these. I don't know why I just came. And this is 4.425. And then the median is 4.16. 4.16 is actually closer down here, so I'm going to put that here. 4.16. And 4.06 is a little bit, not too far away from this, so 4.06. But 4.71, that's 0.3 above this. So I'm going to make this a little bit longer, and 4.71. So that's the 5-number, that's the box and whisker plot using the 5-number summary that I got right off my calculator. And that makes it pretty easy. That makes it pretty easy to do. Let's talk real quick about the box and whisker plot. It's going to have a whisker, it's going to have a box, and it's going to have another whisker. Over here goes the max. Over here goes the min. This is quartile 1. In the middle, now it's not necessarily in the middle of the box. If it's closer to quartile 1, you put it closer to quartile 1. If it's closer to quartile 3, you put it closer to quartile 3. And this is either quartile 2, but most of us will just call it the median. Quartile 2 and the median are basically the same thing. They represent where 50% of the data is above and 50% of the data is below. Now I'm going to erase that because I want to make sure you understand something. I could have a box and whisker plot that looks like this. And this kind of throws some kids off. Where very few kids, or 50% of the kids scored in this down in this range. And the top 50% were really spread out. Like, you know, this could be like, let's say 50, 52, 55, 90, no, let's go 80 and 100, right? So I can have 50% of my kids here way down this range, and then the other 50% could be all spread out from 55 to 100. So it doesn't necessarily mean it's got to look exactly, and it shouldn't almost ever look exactly symmetrical like that. Almost never. All right, so this is not true, just by the way. I just want you to know this. But let's just say Mr. Johnson's girls' heads were all in the 99th percentile. What does that mean? That means their heads were bigger than 99% of all babies tested. Now, in this case, because those tests that they do at the hospitals are across the board United States, you could almost say all babies, because those are standardized tests that they give to all babies across the United States in every hospital. If your SAT score puts you at the 65th percentile, what does that mean? In what? In English or math? Or maybe it's the whole score. That means you did better. You did better than 65% of all students. Now, not all students. Which students? All students who took that exam. Or another way you could say it, if you're one of those people that likes to look ahead, not behind, you could say that 35% of the people beat you. But when we're talking about percentile, it really means 65% of the people, you beat 65% of the people that took the test. If you scored a 95% on your chemistry test, does that put you in the 95th percentile? No, not at all. All it means is that you got a 95 on the test. You could have been in the 99th percentile and beat everybody, almost everybody on the test. 99th percentile. You could have been in the 80th percentile. Maybe 20% of the kids got better than. Maybe a whole bunch of kids got 100 on the test. Maybe even 80 percentile. That's not what it means, okay? All right, let's keep going. So we talked about quartiles, right? This is our 5-number summary. Lowest, quartile 1, quartile 2, quartile 3, and our highest score. We've talked about interquartile range. These are things you have to have memorized. So let's say if we're going to find the interquartile range for this data, it should be pretty obvious. Once I put this in the calculator. So let me get rid of this garbage. Why am I in radian mode? I'm in radian mode again, kids. I'm not very happy about that. I'm not going to lie. Oops. Not on the right page here. Moving on. Oops, there it is. Now I'm on the right page. Oh, so this one has frequency. This is score. Wait. Oh, score and frequency. I was supposed to do that. 140, 145, 150, 160, 170, 180, and 194. Man, my eyes are all bugging out. Maybe I need more coffee. No, I don't. Don't need any more coffee. Yes, I do. Yes, I do. No, I don't. No, I don't. 4, 3, 2, 4, 3, 2, 3, 2, 2, 1. 3, 2, 2, 1. Okay, we got everything. Got it all in there. So since we have a frequency, we got to be careful. We're going to go into menu. We're going to go into statistics, stack calculations, score. Nope, clicked on the wrong thing. Gosh, sometimes this calculator does all kinds of stack calculations, and then I got to go to one variable statistic. I knew I missed something. So we're going to put in score, and we're going to put in frequency, and we'll click OK. So if it's asking for the interquartile range, I don't know why I'm doing 6. For some reason I'm doing 6. I'm only going to do one of these because you don't need to see this 6 times. It's pretty obvious what this is. So I'm going to do the interquartile range. Apparently I'm doing it of question 6, not 5. I just completely skipped that. And 170 and 142.5. So if I come back here, I'm doing this. I'm going to do quartile 1 is 142.5. And quartile 3 is 170. So anyway, in order to find, I'm sorry, I took a break there. I had to do something. Anyway, so in order to find the interquartile range, we'll just take these two and subtract them. And if you subtract those, you get what? 27.5? Sounds about right. Let's talk about standard deviation. So this is a huge topic. Millions of dollars are spent on learning what the standard deviation is. Standard deviation, according to Wikipedia, in statistics, the standard deviation, SD, or STD. Okay, I don't think we want to call it an STD because that sounds like something else. So anyway, is represented by the Greek letter sigma. Is a measure that is used to quantify the amount or variation or dispersion of a set of data or values. A standard deviation close to 0 indicates the data points tend to be very close to the mean. Sometimes we call that mean the expected value, and you heard me call it that a few times. While the high standard deviation means the data points are spread out all over the place in a wider range of values. Okay, so what do we use standard deviation for? We use it to determine, it's used, nope, that's not what I want. All of a sudden I just blanked on what I wanted to put in here because I want to make it in layman's terms, Krauss terms, layman's terms. Let's just say this. It shows us how spread out the data is. Shows us how spread out the data is. It's a number that shows us, again, how spread out the data, how dispersed the data is. If the data is close to 0, it's very consistent, which means not spread out. Not spread out. If it's a large, now I can't, if this is a large number, and I can't say what a large number is. You know, if I'm talking about a large number when I'm measuring microscopic organisms, it might be 100th of a millimeter. But when I'm talking about dispersion or a large standard deviation of horse heights, you know, that might be a foot. So I can't tell you what it is. But a large dispersion means they're all spread out like crazy. Now, variance is another form of determining how spread out the data is. I can't give you a real good example of why we would ever want to use variance right now, only because, you know, I know they use it some in statistics. It's always positive. It's always positive. And the reason it's always positive is it is the square, it's always positive, it is the square root, or excuse me, it is the standard deviation squared. So whenever you square something, you're going to get something positive. And it's also, so if you basically just take the standard deviation, you square it, you can see if standard deviation tells you the spread, variance will also tell you the spread. And I think it's just used in higher calculations when you're doing some more, maybe more intense statistics. But anyway, what you need to remember for as far as Algebra 2 this year goes, and Mr. Whoever your AP Stats teacher in our building, it's Mr. Johnson or Mr. Ikas, they'll teach you some more uses for variance. What you need to remember is it's the standard deviation squared. So let's give you an example. Got this example from a friend of mine. Let's talk about dog heights. You know, we've got this big dark dog, black dog here. I can't remember the name of it. It looks cool. I have a dachshund. My dachshund's name is Ruby. So this is Ruby. But I don't have one of these other dogs. I do have another dog, but it doesn't look like this. Got a greyhound. But anyway, we measure their heights to be these. So you measure at the shoulder. And let me get those numbers into my calculator. I'll come back over here to my calculator. I'll close out. Go back in. No, I don't want to save. These are heights. Heights. Why does that? I just want to go on. All right, so my heights are 600, 470, 170, 430, and 300. 5 dog heights. And it's only one variable, so I'll do my one variable statistics, menu, statistics, stat calculations, one variable statistics, one list. My list is heights. And we click OK. And I find out that the mean is 394. $394. My standard deviation, now here's the problem. When I'm looking at these, I can have one of two standard deviations. So what is this test? This test, you and your friends have measured the heights of your dogs in millimeters. So we're only testing our dogs. We apparently have 5 dogs. So that is the population of dogs. Now the reason I say that is because you have 2 standard deviations over here. You've got this one, this SX, that stands for the sample standard deviation. And you have this sigma x, which stands for the population standard deviation. In general, you'll always use the population unless in the problem it says it's a sample. Or you read in there that they took a random sample. If they took a random sample, use the sample standard deviation. If not, you use the population. So we'll use the population since this is all of our dogs. 147.323. So 147.323. And then the variance, if you remember correctly, is just the square of that. So I got to actually, it's not going to be in my list. I actually got to come over here and go 147.323 and square it. Now you're going to see this is a rather large number. 21704.1. 21704.10. So I'm not sure how 21,704 millimeters, 0.1, of a variance tells us much about how spread out this data is. But this 147 I can understand. Here's my average. My mean or my average, this is my expected value, is 394 millimeters. So what I would expect many of these dogs to be 147 millimeters above or 147 millimeters below this line. So if you come over here and look at it without the dogs on it, this dog was clearly above that 147. It's 206 above. But this dog, that's within 147. This dog is not. So this was the dachshund, and this was that great big dog, whatever it's called. The other 3 dogs that were tested right here, we were within that 147 days. Remember, it's within, you're looking for within, in this case, 147 or or one standard deviation from the expected value or mean. And you should find most of your dogs with this within that. these ones later will determine if they really truly are outliers. In order for them to be outliers, there's actually a definition for them to be outliers. It's 1.5 times the interquartile range. So we'll define that and describe that later. But generally speaking, when you have dogs or whatever data points that are way on the outside, they're called outliers, and they kind of mess up your data. So anyway, why is standard deviation good? Well, millions, actually billions of dollars is spent on standard deviation because, and I'm not going to write anything in there, but billions of dollars is spent on standard deviation because what you're looking for is whenever you're testing something, you're trying to find out what's normal, what's working. For example, if I wanted to test who's coming into my store, I'd mark. And if I found out that 90%, or, you know, I could find out, you know, the general expected age of kids coming in, people coming into my store were 15 or 16 or 15.5 years old. And the standard deviation was like 2 years. So I was like, oh, between like 13 and a half and 17 and a half, those are the kids coming into my store. I could expect most of those people coming into my store. So then I would create my store and set my store up so it would cater to those people. If I found out, though, that my average or expected value was 50 and my standard deviation was 20, well, that means I got people from 30 to 70 coming in. Well, how do I set up my store for that? How do I determine that? Right? But at least it tells me something that's going on about my stores. They use it a lot in medicine. You know, if I find out this medicine works, this dosage of medicine works, and it works for, you know, my standard deviation is very small, so most of the people that are around this dosage, it helps. That's great. That's great. If I can get most of those people within one, and my standard deviation is small, I'm like, wow. If, you know, let's say it's 200 cc's of this medicine works, and the standard deviation is 5. Well, from 195 to 205, I get almost all of the people that are in this study that this medicine helps for. That's great. If the standard deviation was 100, that means we go from 100 to 300 cc's, then maybe this medicine isn't great. So we use it a lot just to kind of see how what the data looks like. So let's talk a little bit. Oh, small standard deviation, and we've already talked about this. A small standard deviation is it's a tight group. It's less dispersed, or it's less spread out. And then obviously a large standard deviation is highly spread out. I don't know if that's even highly. Yeah, that makes sense. Spread out. All right, let's keep going. All right, so I'm only going to do one of these. Let's do the standard deviation for these numbers right here. I'll put them in my calculator. I think we can handle this. Where'd my calculator go? There it is. Let me get those numbers in there. Go to my home. Go to my spreadsheet. Get out of my spreadsheet. We'll just do this. What were these things? Let's call them numbers because that's all it said. Numbers. We've got numbers. I don't know what the numbers are, but we got numbers. 75, 83, 96, 100, 121, 125. See, screwed up already. 125. All right, so if I put those in there and I go menu, statistics, stat calculations, one variable statistics, I've got one list. I call them numbers because they're really important. Now notice that I have heights here. That's from my first spreadsheet. That's why you generally want to get rid of, and I should have gotten rid of my spreadsheets and gotten a new one. But luckily I didn't call it the same name and choose OK. So in this case, my average, my X bar, or my expected value is 100. So my X bar is 100. And my standard deviation, now, see, it didn't say sample, so I'm going to go with sigma x, my population standard deviation, because it didn't say it was a sample, so these were the numbers. 18.239. 18.239 is my sigma, and that's my standard deviation. That's the answer to this question. All right. Well, I put two things together here. I've put the standard deviation number line together with this thing that's on the bottom of your formula sheet that you will now probably wondering all year long, what the world is that? That's your normal or standard deviation curve. Normal curve for standard deviation. Now, you'll notice in the middle we have a 0. that stands for X bar. That is your expected value. You would expect your mean or average to be right here. That would be where your average is. This is your mean. Now, if I go to the right, 1 standard deviation. That's why I'm adding 1 sigma, 1 standard deviation. Now, on the normal distribution curve, you'll just see a 1. And if I go to the left, 1 standard deviation. That's minus 1. In this case, you'll just see a minus 1. Well, you notice here, there's a lot. We're talking about the area under this curve, and you're going to learn that in calculus and AP Stats. But what I would expect, if the data is normal, and lots of things in life are normal, not all of them, lots and lots of things in life are normal. Later on, you'll talk about skew. I could add all of these up, and if I add all of these numbers up, I would find out that 68.2% fall within 1 standard deviation. So if I go 1 standard deviation below and 1 standard deviation above, I get 68.2% of my data. Okay, so let me erase that. What if I went up 2 standard deviations? And quite honestly, I don't remember what this number is. I don't have these memorized. I will by the end of this unit again. But you'll notice, what happens when I go out 2 standard deviations? Holy mackerel, I got all kinds of things. Let me just get the number for you because I forgot what it was. It's 68.2 plus. Now I'm going to add in these. I already added in all these. I'm just going to add in these 2 9.2s and these 2 4.4s. So what was that? 18.4. So plus 18.4. Plus 8.8. I think it's 95, something like that. 95.4, yeah, that's what I thought. So 95.4. So between 2 standard deviations below and 2 standard deviations above, you got 95.4. Now, if I go out 3 standard deviations, that's way out here and way out here. Well, all I'm missing is this 0.1 and this 0.1. Well, that's 99.8% of all people are within 3 standard deviations. So you know if you scored above 3 standard deviations, you're like crazy. You're way out here in the extremevilles. So let's talk about this. Ralph and Gloria recorded their mileage in their cars. Okay, now here's the first time we're going to use 2 lists. So we're going to go in our spreadsheet, home, spreadsheet, get rid of all that crap because I got lots of stuff saved. Bam. So I'm going to call this Ralph. And what was it, Nancy? No, Gloria. Gloria. 22.3. Oh, I got it right here. 21.2. 20.8. You can just skip this if you want. And go ahead a little bit. Don't skip everything, though. You want to make sure you see how I get these 2 lists in. So I type those 2 lists in. Now I'm going to do Gloria's list. 25.2, 19.1. What? Scared you. 18.8, 24.4, and 20.3. Okay, so I've got the 2 lists in. I'm going to put my cursor here again, or my pointer here, and I'm going to come back over here to menu. We're going to do statistics. We're going to do stat calculations. We're going to do 1 variable statistics because it's still 1 variable. It's gas mileage. But I now have 2 lists. So I'm going to click this to 2 and click OK. Now it says X list 1 is what? Well, X list 1 was Ralph. X list 2 was Gloria. And it's going to start putting the results in D, so that's fine. So I spread these out. You'll see this is Ralph, and this is Gloria. So let me get those numbers in. 21.58 for Ralph. Oops. 21.58 for Ralph. And 21.4 for Gloria. The range. All right, so the range value for him was, what's that, 4? So for Ralph was 4, and for Gloria, let's see, she went from 25.2 to 18, so that's like 7.2. So clearly her range looks like it might be more spread out. So I'm going to guess we're going to expect her sample standard deviation to be higher. Since it says sample standard deviation, that's what we're going to do. I'm going to come up here to sample standard deviation. And his is 1.5. And 1.53. And hers is 3.22. So hers is like double spread out than his. And I'm going to guess it's probably because Gloria, I hate to say it, is not as effective as a driver. She probably slams on the gas and hits the brake and slams on the gas and hits the brake, you know, as opposed to Ralph, who's probably 60 or 70 years old, and just kind of goes at a nice easy pace. So whose mileage was more consistent? Ralph's was more consistent because his numbers, his spread out, were spread only within 1.53. So you could take his 21.58 and go out 1.53 this way and go out 1.53 this way, and you would expect 68% of his mileage, 68.2, to be within 1 standard deviation. All right, I'm going to put these in. If you want to, you can quickly fast forward past. I'm going to put these hatchlings in. So I'm going to close out, not save, go back in. Again, you can fast forward to this if you'd like. What are these things? We'll call them hatch. And we'll come down here, and I'll put them in. 55.7, 85.2, 51.5, 12.7, that's crazy, 38.5, 90.3, that's crazy high, 70. These are all over the place. 39 point, see how they're spread out? I'm guessing we're going to have a huge standard deviation. And 48. All right, so I got them all in, all 10 hatchling percentages. We'll go into menu, stats, stat calculations, one variable stats, one list. It's called hatch. And there we go. So the X bar is 55.67. So the X bar is 55.67. Here's 10th. So 55.7. The sample, this is only a sample of ducks surviving, so, well, it didn't say sample, so we're going to use sigma x. And so the standard deviation is, we got to use the sigma x, 21.98. So actually that's 22.0, because we rounded the nearest 22.0, rounded the nearest tens place. My variance, which would be the standard deviation squared, would be 22 squared. Well, it's actually, excuse me, it's, how do I go back? Nope. No, I can do it this way. I don't like doing it this way because it's going to open a new one. Let's just go back. The variance was 21.98, so we'll take 21.98 and square it. Why am I in a graph mode? 21.98 squared, 483.1. This should be 483.1. And finally, my range would be highest minus lowest. So back, back, back. So my highest was 90.3 minus 12.7. So 90.3 minus 12.7, I get 77.6. So my range is 77.6. So how many percentages fall within 1 standard deviation of the mean? So that's what we got to figure out. So our mean is 55.7. I'm going to add my standard deviation of 22, and I get 77.7. If I take it and I subtract 22, I get 33.7. 0.7. So I want to come up here and highlight all the ones that are between these two numbers. So 55.7. Oh, man. That is the mean. That's in there. 85 is not. 51.5 is. 12 is not. Is 38? Yes, 38 is. 90, no. 70? Yes. 39? Yes. 65? Yes. And 48? Yes. So you'll see that of my things, 1, 2, 3, 4, 5, 6, 7, 7 out of the 10, or 70%, are within 1 standard deviation. And if you remember from our drawing here, within 1 standard deviation, this area right here, if you add all that up, that's 68.2. So this is pretty accurate normal distribution. All right, I'm going to put these scores in. Might want to pause or just go ahead. Skip ahead a little bit while I put these in. See, that's why it's not going to take long. The video might be long, but you're not going to. You can skip ahead while I put all these in. Let's see, what are these? Prices. So 2.1, 1.95, 2.6, 2, 1.85, 2.25, 2.15, and 2.25. Go in, do the menu, stats, stat calculations, and one variable statistics. Yes. We called them prices. Click yes. You could have called them lures if you wanted. So the average price, or the mean price, was $2.14. So the X bar is $2.14. Now they said there's 8 different types of lures, so we're going to do Sigma X. Sounds like they have it right. Have all of them tested. So that's 0.22 or 22 cents. My range would be max minus min, which would be 2.6 and 0.1, so $2.60 and $1.85, so that's 75 cents. So my range is 75 cents. And my variance, oh shoot. So my variance is, I have to take that 0.217, so go to my calculator, 0.217 and square it, and I get 0.047. 0.047. So my variance, which is my sigma x squared, is equal to 0.047. All right, so how many prices fall within 1 standard deviation of the mean? So I take the mean, $2.14, and I'm going to add 22 cents, and I get $2.36, and I'm going to subtract 22 cents. Let's see, subtract 14 cents, that's another 8 cents, this is $1.92. So how much are between $1.92 and $2.36? That is just barely. Nope, too high. That is 185 too low. 225. Yep. 215. Yep. 225. Yep. So in this case, it's 1, 2, 3, 4, 5, 6 out of 8. 6 out of 8 is 75%. It's a little higher than the 68.2, but it's not bad. All right, you're definitely going to want to pause it while I type these in because I got to put 47 numbers in. So it's going to take me a couple of minutes. So fast forward or pause this thing, or yeah, I would fast forward. If you'd want, I'm going to sit here and talk to you while I do this. I'll make fun of some people. I don't know who. Got to think of who's going to come to mind. Who annoys me the most? Let's see. What are these things? Rats. Survival times. Well, how sad is that? Survival. All right, survival. So 43, 74, almost 84, 102, 156, 45. Are you still listening to me? Man, you guys have no life. Fast forward. Get past all this. Oh, you're just waiting for me to make... I mean, I won't make fun of anybody. See, if I make fun of anybody on video and it goes viral and it goes live, then I got parents going, oh my gosh, that Mr. Krause is so mean to all of his annoying children. Oh, wait, I said annoying. I don't have annoying children. Oh, yeah, I do. Maybe I should just do initials of annoyingness. And then I could like, no, that's not who I meant. Yeah, arm. 56. You know who I'm talking about. You're not annoying, man. You're a great kid. Man, these are a lot of numbers. How many think they could actually type in all these numbers and not make a mistake? How many on their Regents exam would go through and actually do this 2 or 3 times to make sure they didn't make a mistake? I would. That's how you get 100. And you get really lucky. 58... 81, 97, 121. I hope I'm not making a mistake because I'm actually not going to take the time to go through these because this is not that highest stakes exam for me. But if this was a high stakes exam, I sure the heck would be doing these over and over again. 66, 82, 99, 137, almost done. 67, 83, 100, 139. When I was young, we had to do these by crazy methods. You don't have to do that anymore. Now, I'm a little miffed because I came up with 49, and there's only supposed to be 46. So let me see. 1, 2, 3, 4, 5, 10, 15, 20, 25. 1, 2, 3, 4, 5, 25. That doesn't make any sense. 1, 2, 3, 4, 5, 25. 36, 37, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. There should be only 45. Somehow I must have added a whole lot. I must have done a column twice. Doggone it. I do have to check. 43, 74, 84, 102, 156, 45, 79, 88, 103, 171, 53, 80, 91, 107, 191, 56, 80, 92, 109, 211, 56, 81. That's just annoying. 81, 92, 114, 243, 57, 81, 97, 121, 58, 81, 90, 50, 57, 81, 97, 121, and 58, 81, 99, 126. I'll bet that's where it is, right there, right? There, I did it again. So delete, 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 and delete. All right, so I think I'm good. I think it'll handle the fact I screwed those up. I got those out of there. Menu, stats. Let's see. We'll find out in a second. Stat calculations, one list. Call them survival. Click OK. Does it say I have 45 numbers? Yes. So got them all, even though I had to delete some. All right, so if you stayed with me that whole time, wow, that's really weird. Wow, look at my mean. Is 99.9. So find the range mean. So let's go through. Mean. That's X bar. 99.91. Or 99.9 because they only went to 1 to 10th place. Okay. So then my standard deviation. So this must have been all 45 rats. So this is our population. We'll use sigma. 41.9. 41.9. My range we'll come back to, and we'll get my variance. So my sigma x squared. So my range is highest minus lowest. So that would be 243 minus 43. Oh, that'd be 200. So my range is 200. And my variance is going to be 41.9 squared. So 41.9. We'll just use that squared. 1755.61. 1755.61. So how many prices fall within Stu Tanner's? How many prices? Dude, seriously? I copied and pasted and screwed that up. How many survival times fall within 2 standard deviations of the mean? So what we'll do is we'll take the mean, which is basically 100, so 99.9, and we'll add to it 41.9. So that's 0.2 less than 40. And then we got to add 41.9 again because we're going 2 standard deviations away. So if I add those up, 99.9 plus 2 times 41.9, I get 183.7. And if I go down, I'm going to do the same thing, but this time I'm going to subtract. And this video is an hour long. 16.1. All right. So I got to highlight all the ones. Yeah, that's kind of a pain. 16.1 all the way to 183.7. So hopefully I don't screw that up. Let's just do, we'll do the low end. Well, no, can't do that. That's higher than 16, 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 higher than 16. This one is not. This one is not. These three are not. Oh, these are in order. That's nice. So all of those work. All the way up to 183. And all of these work. Oh. All of these work. And all of these work. And all of these work. There actually wasn't anything low, down to 16. So they're everything but these top 3 work. That's it. We're good. I didn't even realize they were in order. That was kind of silly. I think that's it. I'm done. Yay! Done with day 2. That was a lot of work, kids. But luckily, you only had to watch from like here down. So maybe it was only 20 minutes. Hopefully, it was only 20 minutes. Anyway, thanks for coming. Enjoy. Have a nice weekend. I got more videos coming. Yes, it's going to be a video day because I'm out 2 days next week. Bye, kids.